investigating the primary production of Bear Lake's filamentous algal blooms. Filamentous algal blooms, or FABs, have recently been identified on the western shore of Bear Lake near the USU Research Center. While FABs have been anecdotally occurring in the lake in prior years, the spatial and temporal extent of their occurrence, the range of species present, and the underlying driving mechanisms are unknown. FABs have been widely considered a puzzling phenomenon, as they are occurring with increasing frequency in clear water lakes and streams around the world, with no apparent unified driver. Potential drivers include groundwater nutrient enrichment, warming water temperatures, chronic changes in the nitrogen-phosphorus ratios in surface waters, and declines of key grazers via pesticides or food web interactions. Likewise, unknown in the food web and metabolic role played by such FABs, benthic algae can play an incredibly important and often overlooked role as a major supply of autochthonous organic carbon, especially in clear water lakes. Moderate nutrient concentration coupled with clear water may provide ideal situations for high benthic primary production rates, which may be significant at a whole lake scale and important for fish, which here includes several endemic species and a sports fishery. However, counterintuitively, high rates of benthic primary production may be associated with low standing stock periphyton biomass under heavily grazed conditions, and high periphyton biomass is not necessarily associated with elevated rates of primary production. In other words, more is not necessarily better when considering FABs. Long strands of filamentous algae can also be difficult for aquatic animals to graze upon, and thus FABs may be further associated with a decline in supply of benthic algae to the lake's food web. 3 campaigns were done in June, July, and October. Each sampling campaign, except for June, due to a lack of time, was focused on 2 areas of the lake where FABs were predicted to occur. One location on the lake's western shore at USU Bear Lake Research Facility near Garden City, where FABs were first identified in late 2019, and the second location was determined by scouting along the lake's eastern shores. These 2 site locations were chosen to potentially capture different FAB driving mechanisms. The western shore of Bear Lake is more heavily urbanized and may experience groundwater nutrient pollution as a driver of FABs, while the eastern shore is rocky and bare, which typically provides favorable substrate for benthic primary producers. At each field site and during each campaign, YSI meter and algal sampling was carried out in situ light-dark metabolism experiments to quantify algal community metabolic rates, gross primary production, net ecosystem, and community respiration. 14 sealable glass chambers were used at each research site, with half of these chambers being dark treatments prepared inside a cooler and sealed shut to measure community respiration, and half being light treatments measuring NEP. There were 2 control chambers, one light and one dark, with just lake water in them to quantify the local water column metabolism rates. In Figure 3, it can be seen that gross primary production is strongly and negatively correlated to periphyton biomass, with a p-value of 0.0176. Thus, surprisingly, the more periphyton biomass there is on a rock, the less productive it is. In Figure 1, periphyton biomass is compared between the 2 sites. In the USU site, the shores had strongly visible algae establishments on the rocks, and in the eastern site, there was very little visible algae found on the rocks. In Figure 1, there are visible differences between the 2 sites in biomass growth. In Figure 2, the amount of gross primary production and periphyton biomass was compared between the 2 sites. The east site that had little visible algae showed significantly higher amounts of GPP per unit of periphyton biomass, leading us to conclude that the less biomass, the more productive an ecosystem is. In summary, these filamentous algal blooms in Bear Lake may be harming the ecosystem rather than helping it due to the lack of efficiency of gross primary production. These are usually the signs of eutrophication in the lake and can be what is currently happening in Bear Lake.